myself, and I'm going to talk about me and Kraken technologies. Then we are going to talk about the main topic, which is how to ensure high code quality while contributing to a single global repository. To answer this question, we will go through 4 main points: the way that we set up our continuous integration pipeline, the way that we control manual interventions in Kraken, how we do efficient reviews, and how do we share knowledge within the organization. And at the very end of the talk, I will also go through the challenges and limitations of the other methods that I will talk about. So starting a little bit about me, my previous job was as quality assurance engineer. I was basically working doing automated testing frameworks for desktop applications related to automated guided vehicles. Since almost 2 years ago, I joined Kraken as a backend developer, and today I'm a tech lead of a backend team in Kraken Europe. Why did I decide to give this talk? Basically, I wanted to share my experience growing from a junior to a more experienced developer. And starting as a backend developer in Kraken can be overwhelming, as my colleagues may know. The repository is huge, and we are more than 500 developers working on the same repository. So I wanted to share the lessons learned over these last 2 years and the way that we work in Kraken, keeping quality in mind. A little disclaimer about this talk. It will mainly be focused on Python and Django, because that's the backend framework that we use in Kraken. Most of the things can be applied to other programming languages or frameworks, but because it's how we work, I will do a lot of references to Django. A little bit about Kraken technologies. So you may have seen our booth downstairs, which is called Octopus Energy. Actually, Octopus Energy and Kraken are part of the Octopus group. So Octopus Energy is the energy supplier, and that uses Kraken as the energy tech platform. However, also other clients use Kraken, not only Octopus Energy. So what is the Kraken software? So Kraken handles business operations and customer relations for the energy market mainly. It aims to have simple processes with straightforward interactions with the software. And to do that, we always keep the customer in mind. So we try to make the interactions customer-centric. We try to really listen to the feedback of our customers. And when I mean customers, it can be either the energy specialists that work in the energy supply companies or the end users, so the customers that buy the energy, so that hire the supplier. And we try to improve their user experience as much as we can. As of now, Kraken is licensed to support over 30 million accounts worldwide. So you can see that it's a very big software. And talking code-wise, it is a monolithic repository. What does it mean? Here you have a little diagram. It may be a bit little. But it means that most of the project is contained in a single repository. So the core of Kraken is in a single repository that from now on I will refer as Kraken core. And it's the one that I will be talking about in this talk. In Kraken, we also develop microservices that communicate with Kraken via API, but the big part of Kraken, so the core of it, is in a single repository. And this repository follows a layered architecture with certain standards to be followed. So we have, for example, the application layer, which is the layer exposed to the end user. So it's where we have, for example, the APIs or the Django views. And in that layer, we do not write any code that writes on the database directly. In order to do that, we have the domain layer, which is like one layer below. There we have the methods to create data, to update data, or to modify objects in the database. And in the application layer, we will call these domain methods. And then we have another layer underneath that, that is the data layer or database layer. And that's where we create our models, where we store the models. Kraken right now is in 9 territories. This presentation will probably be out of date soon because we are growing very fast. We have multiple clients per territory. So that means that as developers, that we all push into the same repository. Every time that something gets merged into the master branch, that will get deployed in all the Kraken clients. And we deploy around, here I put 80 plus, it's more around 100 deploys per day. And yeah, so we should make sure that those changes that we are pushing to the master branch will not break any Kraken client. And how can we do that? So this is the question that we will answer here. The idea here is that humans make mistakes. And we try to answer the question when we develop, how can I do my work so that nothing can fail? And if something fails, how can I make a process that will tell me that something is failing? And the idea here is to have different code quality processes. And one of them is being that we do not allow developers to merge code if something does not follow the standards or if something breaks the code base. And to do that, we have a very big continuous integration pipeline. When a developer pushes into the into the Kraken core repository, the commit will go through the continuous integration pipeline. Right now, every time we push into like a branch, it takes around 20 minutes maybe to run the whole continuous integration pipeline. It's quite huge. I don't know the number of tests. I guess it's around 160 test suites, but each test suite has a lot of tests, sometimes 100 or more. So it ends up being a lot of tests. And we basically have different kinds. The first kind is the unit, integration, and functional tests. These are tests written by the developers when they are developing. The unit tests are simple tests that aim to test the functionality of a method without any database interaction. So we do not test anything related to the database. We just have a method, like here, a validator, and we make sure that the behavior is as expected. Then we have the integration tests, that those ones do interact with the database. So what we want to test here is that having a method, we are updating the database correctly. So we are either creating objects or modifying its fields or deleting an object. And in this example, it's a test to check that we are sending the communications when we create a new account correctly. So what we call onboarding is to create a new account for a customer. So in the test, we first create an account, then we have the action, which is to send the communications, and then we assert that the object message, which is the email, is created in the database correctly. And then we have the third kind of tests, which are functional tests. These tests, much like the integration test, do have database access and want to check if we update the objects in the database correctly. But the specificity is that functional tests are mainly used to test interfaces. So either APIs or Django views or even management commands. So something that the end users will do directly. In this test, for example, we are testing an endpoint and we are asserting its response. So the assert doesn't always need to be database related, it can also be the response of a call. Moving on, we have other kinds of tests, which are the basic code quality tests. So you may know them already, like linters, checkers, black, isort, mypy, flake8, and many more that we have. But then the most interesting ones are the automated tests that we have to enforce standards and architectural principles. So some examples that we have are the file names. Sorry. So in Kraken, we do not allow the user, like the developers, to put any characters in the file names. There are certain restrictions. And we have specialized tests that will fail if we put a file name which doesn't follow the conventions. Same for test files location. Our idea is to have a test file location that mirrors the location of the file in the code base. If I show an example, maybe it's easier to understand. So if we have the code, which is called operations.py, which is in a folder accounts, which is in a folder domain, in the test folder, we should have a folder called accounts, and then another one called domain, and then test operations. This way, we can easily see if we are testing the file that we have created. And then the database access on different tests. As I mentioned, the unit test shouldn't have any database access. So we have tests that will fail if we try to access the database in a unit test. Basically, it will just tell us, don't you want it to put it in an integration test or a functional test? So with these automated tests, for example, circular dependencies are almost impossible some tests will fail almost for sure. And then that's a way to prevent developers to add a code that could break the code base. Even if we have an automated pipeline to ensure that the standards are followed and nothing seems to break, there are still things that cannot be automated. So manual interventions, stuff that you cannot automate. And in this category, I would like to classify 3 kinds of practices. We have the safe practices that are allowed to everyone. So an example could be to add code to the repository via a pull request. A note here is that in Kraken, if, for example, there is about to be a new release of the product or something that is business critical, we increase the number of reviews required in order to add code to the master branch. So if usually we need only 1 approval, in case something is critical for some reason, we increase it to 2 or 3 approvals. Then we make sure that more people look into our changes. Another practice is the revert of a pull request. So this is allowed to all developers, and is done via a fixed forward commit. If we were doing a rollback, like rewriting history, it would be dangerous, but making it as a fixed forward, there shouldn't be any danger to miss some code before. Then we have dangerous practices that are allowed to very few users, such as accessing directly the Django admin in production, or accessing the production database. So the way that we handle this is to do workarounds to do things safely. So in the case of Django admin, most of the developers do not see the Django admin. They see something called Kraken admin, which is on top of Django admin and has certain limitations. Like, for example, if we were allowing the developers to delete an account in the Django admin, that could be dangerous if it is done by mistake. So there are certain restrictions in this Kraken admin, and very few people, like if we are more than 500 developers in Kraken core, I guess around 10 people or maybe even less have access to the original Django admin. And access to the production database, we can all see the production database, but we do not see the direct database. We see a replica of that, because if we were accessing directly the production database, there could be a risk of blocking the database. And then we have risky practices, which are allowed, but we require an extra pair of eyes. So one example are the configuration files. So we allow everyone to add configuration files into Kraken, but these are sensitive changes that could break potentially the product, so we should make sure that someone specialized in that domain looks at that. So for example, if I'm adding a config file for billing, then someone from the billing domain should look at that. Another example are migrations, which I'm going to explain a bit more closely. How do we deal with database changes, which in Django are called migrations? So migrations are Django's way of propagating database changes, such as adding a field to the database table, or creating a new database table, or deleting a field, and many more. These are usually sensitive pull requests, as we could potentially have a Django programming error that wouldn't let us continue with our development in a correct way. Due to the sensitive nature of these pull requests, we advise that those PRs should be reviewed by more experienced developers. What do I mean? It can be someone more experienced in Kraken, so someone that is familiar with the product and would realize something that someone who is new to Kraken wouldn't realize, and also more experience code-wise, so more experience with Python or with the Django framework. And yeah, in this way, we would prevent potential failures to happen, like having a default value that would potentially break the product or others. We have some other recommendations as well on how to deal with database changes. One of them is to rebase the pull request with the master branch before merging. Actually, this applies to all pull requests. I have added it here, but every time that we want to add a change to Kraken, we should make sure that we have the latest version of master in our branch. Otherwise, we may result in some conflicts. And rebasing is basically taking the latest version of master into our branch and be sure that we are updated with master. And then another recommendation is to keep the pull request with migrations as simple as possible so that they can be reverted easily. Ideally, a pull request with a migration should only contain the migration, so the change in the model, and then the migration file. As you can see, a way that we use to enforce standards or recommendations is through the pull request review. It makes sense because that's the stage where we are going to add code to that global repository, so we should be a bit critical about what we add and don't add. So a question that we could ask ourselves is like, how to make pull requests easy to review by developers. So we are a lot of developers, we should try to make our life easier. My colleague Ben gave a talk yesterday about that in many more details, but I'm going to go through a few items that I think are important. So first of all, we should try to keep the commits atomic with a single purpose. So basically, each commit should work by itself. This is an example of a pull request that I did some time ago. So in the first commit, I'm creating a context class. In the second commit, I'm using that context class. And in the third commit, I'm adding unit tests. So I could add the tests in the other commits as well. In this case, I didn't, because it was a huge battery of tests, so I kept it in a separate commit. But here, I could potentially merge each commit in a different pull request, and then they would work perfectly, because once we have created the class, I can make another PR to use that class, and then another PR to add the unit tests for that class. Continuing on this topic, each commit should pass all the continuous integration tests. If a commit works by itself, then it should pass all the continuous integration tests, and we should be safe to merge each commit independently. So something like that. We expect to have a green tick next to each commit in the PR. We should avoid modifying the same functionality in the same pull requests in different commits. So as a reviewer, if I'm reviewing a pull request commit by commit, I look at the first commit, and I see that the developer has changed file A. I add my comments for 15 minutes. I add, 8, 10 comments. Then I go to the second commit, and I realize that the user has changed the same file and the same method, and basically all my commits are obsolete. So I have basically wasted 15 minutes of my time, and also it's not an efficient PR. It's not easy to review for other developers as well. So we should try to prevent that. We should try to keep the same functionality in the same commit, if it's in the same file, and it does the same, basically. And then, quite straightforward, but it's important to add a good description to your pull request. This is an example of a description that I did some time ago. So I was adding the what, the why, and then a screenshot. So what does this pull request do? It was creating a view. Then I explained the details of that view, the restrictions, etc. Why do we need this view? What are the reasons to create this change? And then adding a screenshot or a video is generally good, because for a reviewer, it gives confidence that the developer has tested locally the changes, and then that it doesn't seem to break the Kraken, basically. So far during this talk, we have been talking a lot about ensuring that standards are followed. But how do we know which those standards are? Like, how do we know in Kraken which standards to follow and which not? This is the next topic. How do we ensure that developers follow the same standards? I want to start with a quote that my manager told me a few time ago. Outages are caused by bad code quality processes, not by bad developers. So as I said in the beginning of the talk, humans make errors, and there is no problem in that. Like, we are all human. But if an outage happens, we should make sure that we have processes that will not let us have this outage again. So having an outage once is okay, but having it twice, not so okay. So how do we ensure that we have those standards? How do we share those standards? Well, we have different items. We have tech talks, which we have weekly in Kraken, where a developer talks about either a new feature in Kraken or a new tool available like Datadog in order to analyze our data. Or, we also just share common knowledge like coding conventions or other topics. We have a lot of written documentation. For example, our coding conventions. my colleague Charles gave a good talk yesterday about coding conventions that we have, some of them. And yeah, so we have also handbooks, and we also have documentation in tools like Notion. In this way, we can refer to this documentation in the pull request when we do reviews. We also encourage cross-learning, so pairing sessions, also with people from other domains. So if I'm working in the billing side of Kraken, it can be interesting to do a pairing session with someone working on communications and see how they work and learn from each other. And we learn a lot through reviews, as we have mentioned before. So we refer to our conventions, we refer to the documentation, we refer also to the documentation like Python documentation or Django documentation, so we try to learn from each other through the pull request reviews. And we encourage constant feedback. We try to communicate openly. We have regular feedback sessions, depending on the way that we work, they can call retrospective or other. And we do not have fear in challenging the standards and to suggest new processes and new tools with a good reason behind, of course, because Kraken is huge and making the change can take time, but if we can justify why we want to use this new library or why we want to make this change, then people are really open to change things. It's not fixed. And then I'm going to end my talk talking about the challenges of having such fixed, not fixed, but like following these kind of conventions and standards, and also talking about a limitation when trying to produce optimal code quality. So what are the challenges when following such standards? A fallback of what was commented before is that sometimes focusing too much on the standards can result in no openness to change. What do I mean by that? If, for example, I'm reviewing a pull request and keeping all the standards in mind, maybe I wouldn't keep an open mind to challenge those standards and try to see things differently. Maybe the developer has made this decision for some reason, and we should not be afraid to challenge the standards. The second point that I have put, it's a potential challenge, it doesn't happen always, that the delivery time may increase when we try to make things as perfect as possible. So I may want to have like a super good quality code, but that may take 5 days to do. But then it will probably not break for like 2 years, or I mean, for a lot of years. But then if I try to do things fast and sloppy, I may do it in 1 day, but then after a few months, I need to refactor that code or make changes. So yeah, the delivery time may increase initially, but in the long term, it will be better. And in this way, we need a good planning. So we need to be able to estimate the task time, so how much time we will take to do a change, and then have good planning processes, basically, to achieve that. What are the limitations of trying to get optimal code quality? So I'm going to end the talk with this. Basically, sometimes when we try to optimize our code too much, it can decrease readability of the code. In this example, it may take like 5-10 seconds to understand what this code does, but if I show this code, probably you will know immediately what it does. And it does exactly the same. So one code takes 9 lines, the other one takes 2 lines. Yes, it's more lines of code, but it's more readable. And at the end of the day, we want to make a code that can be taken by any other developer. And yeah, this is the main idea. It is okay to optimize code, but we should keep in mind that it should be transferable and readable. And with this, I would like to end my talk, and thank you all for coming. And feel free to take octopuses when you go out. We have a lot.
Do you have any questions? Okay.
And thank you so much for sharing your experience in the Octopus team, because I think that managing and maintaining that huge repository is an amazing task. I'm curious about if you guys discussed about actually splitting the repo, because I have the fear that, as you said, all the limitations that you have, for example, being agile and that kind of things, could be mitigated a bit, maybe splitting the repo and trying to, dedicate teams to a specific domain of that. I know it's, it's not easy, like splitting all that functionality, but I am curious if you already have these discussions and so on. So,
yeah, we actually do have these discussions. So I just joined Kraken 2 years ago, but I think before Kraken was even more big, and that's why now we have some microservices to have some things. So for example, the readings are aimed to be stored in another microservices. So when I mean the readings, it's the meter reading, so the consumption data of the customers. If we want to store it in the same database as the core of Kraken, that can be a lot of information. So for example, that we have moved it to a microservice. And yeah, we have other microservices for other things. I think the plan is to move a little bit towards that direction, but still keep the core in Kraken. So we like to have this big repository, but yeah, some functionality that may take more database load, maybe it's good to move it to another microservice.
Thank you.
Hello, thank you so much for the talk. When you were talking about Django migrations, I wanted to ask you a question. In my current company, we use Alembic for SQLalchemy migrations. And we sometimes have this problem where two developers are working on different migrations at the same time, and then you have to handle a branch point with the revision IDs. I just wanted to know if you're familiar with this, or how do you handle it? Like, do you use like a tag on the pull request so you don't merge two migrations at the same time to production, or?
I don't think we use a tag, at least I don't. But usually it's the same team working on the same models, because we are divided in domain areas. So usually, it still happens to us sometimes that two people are working in the same model and they merge at the same time, and then we get a problem, then we need to revert one of the pull requests, or we need to fix it in some way. But usually we try to be aware more or less of what people are working on, as we are divided in these domain teams or even subdomain teams sometimes.
Okay, thank you. Thank you. No magic solution there.
Yeah, no magic. It is still a problem.
Hi. First of all, thanks for for sharing the methodology. Sorry. I figured out that you are using. The pipelines are taking so long. I would like to clarify if you are using, for example, in-house runners, because time on CI is often expensive, and I would like to know if you are doing some optimization at that level.
Yes, we are using Circle CI. I don't know if that answers your question. And there is a team dedicated, like the tooling team, that tries to optimize these kind of things. I don't know the details about that, but I know that when I joined, it was taking way longer, so around 35, 40 minutes, and now it's taking around 20 minutes. So I think they are doing some kind of optimizations, but I don't know which ones. I don't know the details.
Cool, thank you.
Yeah.
Thanks for the talk. I would like to ask if you have ever considered to use feature flags for critical features, so you don't deploy from zero to everything, and you have more safely to do that.
Yes, we actually use feature flags, and yeah, it can be useful when we want to have some functionality that we do not want to deploy straight away, or that it's not urgent, so we wouldn't break potentially the code base in that way. So yeah, we do use feature flags in some cases, yeah.
Okay. And also, I would like to ask, because you talk about the pull request, all the things that you write down, and don't you use the task with the most of that information should be in the task? It's not duplicated what you are describing?
Yes, for the description, you mean, of the pull request?
Yeah.
Yeah, I guess this is a bit up to the developer. There are developers that would just add the task directly if the task is well explained. But there are cases where the task is more from a product point of view, not so much development specific. So personally, I always try to add some implementation details in the pull request description. But yes, you're right that if in the task it's well defined, we usually just link the Asana task. I mean, Asana is the place where we have tasks.
Okay.
But yeah, we have it like that. So most of the developers also link the ticket to Asana.
Okay, thank you.
I think we don't have much time for questions, so well, maybe one more. Yeah. What?
There.
Okay.
So, for your company size, you have mentioned that you have a monolithic repository code, no?
Mm-hmm.
So, as a company big as you, why do you use a monolithic repository, not just break it into small parts?
Yeah, this is a good question that we get asked a lot. But the answer, I don't know it, actually. I don't know if any of my colleagues know, but like personally, when I arrived, it was already like that. It's true that we try to move into having some microservices also, like in addition to that monolith. But I do not know what was the initial, why it was decided like that initially. But it works for us. Like the product doesn't break, like almost. Like sometimes, but like most of the times it doesn't. And yeah, so it works quite well. I'm sorry, I don't know the reason.
So thank you so much for joining us. Let's give another big applause for Maria, please.